Okay, with the effective aperture area itself, we will close because I think 5 minutes is there. Okay, so now I have some, see, this is always with respect to receiver, sir, please. Always with respect to what, sir? Receiver. You have to be very clear about this. Okay, effective aperture area means always with respect to receiver. Say, I have some antenna, parabolic antenna like this. Okay, some parabolic antenna. Now the signal is coming in this way. Now the signal is coming in this way. The signal is having some power density. Okay, when it is incident on the antenna, it will have some power density because the power density is function of distance. It is traveling from somewhere else from the transmitter. After a long distance, it is reaching the receiver. When it is reaching the receiver, it will have some power density. When it is reaching the receiver, it will have some power density, power per unit area. Once if it has some power density, I am having some area. So what is the power collected by the antenna? Okay, power collected power collected by the antenna is equal to, okay, already power density is there. If I have more area, I can collect more power. If I have less area, I can collect less power. So that's why this is directly proportional to area. So that is simply the product of area into power density, product of area into power density. Now, see, you are having some area, but the entire area will not collect the power in reality. Only some portion of your physical area will collect the power. Okay, will collect the power. So that's why this area I am going to replace with the aperture area. Okay, aperture area means what? That is the effective area that will be collecting the power. Okay, so this is physical area. So in reality, power collected, okay, total power received is effective aperture area into power density. Okay, this is the correct way to represent. Okay, we expect, okay, because if 100% of the area is there, only 95% or 90% of the area only will be collecting the power. Okay, rest of them will not collect the power. Okay, to define them properly, we are defining the term effective aperture area. That means what? Even though there is some area, how much portion of the area is actually collecting the power? So one thing is very clear here. The physical area is greater than the effective aperture area. That means what? Effective aperture area is less than the physical area. Generally, always effective aperture area is less than the physical area. Then how much it is less? That can be easily calculated from this formula. Okay. Then the relation between physical area and aperture area is defined by this factor. Say, for example, effective aperture area is equal to eta times A. Then eta is called as aperture efficiency. Okay, so mostly it will be more than 90%. That means what? 10% of the plate is not collecting the power, remaining 90% is collecting the power. That is the idea of the aperture efficiency. So this factor eta will give you directly the measure of how much portion of the antenna is collecting the power. Okay, so AE is equal to eta into A. So now I will give you one more equation. Okay, the directivity is having, again, directivity in the case of receiver is equal to 4 pi effective aperture area divided by lambda square. Okay, I will give you an assignment. Okay, please refer from where this formula came. The directivity is equal to 4 pi effective aperture area divided by lambda square. We are using this formula then and there, but we do not know from where it came. Where is the base of this formula? Okay, directivity is related with AE and eta lambda square. Okay, this is somewhat okay because the directivity you are defining for receiver, this is for receiver. If you have more area, there is a chance you will have more gain or more directivity because you are receiving more power somehow. So that's okay, but how it is related with lambda square? Okay, because if it is related with lambda square means it is indirectly related with the f square. Okay, so please look into that from where this formula came. Where is the derivation? Okay, once if it is like this, okay, D is equal to 4 pi effective aperture area divided by lambda square. Then AE I can write like this, lambda square divided by 4 pi and then directivity. Okay, so or otherwise, if this is directive gain, then if this is AE max, effective aperture area max, then this is lambda square divided by 4 pi directivity. So always please, without any confusion, you remember this formula. This is important. Most often we will use this formula. Directivity is equal to 4 pi effective aperture area divided by lambda square. Don't confuse with this formula. Okay, so with this I will stop. If you have any doubt, you can ask. One more minute is there, or otherwise we'll continue on tomorrow. We'll discuss about lambda